Well, welcome everyone. Thank you for joining us. I hope you're having a great conference. We're excited to have you join us to talk about Fannie Mae's practical path to modern PKI and certificate management. I'm Dan. I'm product manager for AWS Private Certificate Authority, joined by my friends Cosmos and Nana from the Information Security Engineering team over at Fannie Mae. So let's get started. Quick agenda. I'm just going to give you a little laydown on what AWS certificate services are, so you get an understanding of what we do, as well as some key concepts that will help you follow along Cosmos and Nana's portion of this session. Then they're going to actually go in, talk about what they did, and the challenges they faced, as well as the lessons they learned. And at the end, we'll do a quick wrap-up of key takeaways from the talk. So what are the AWS certificate services? First, we have AWS Private Certificate Authority, or AWS Private CA. This is a highly versatile CA, allows you to create entire CA hierarchies in the cloud, gives you the ability to issue private certificates, whether it is for mutual TLS devices, users, IoT devices as well. And it comes with fully managed revocation, so you can use certificate revocation list or online certificate status protocol. The other service is AWS Certificate Manager. It makes it really easy for you to get public certificates, public TLS certificates, and private TLS certificates to use with AWS service endpoints and hosts. So I'll start with AWS Certificate Manager, or ACM. So what is it? I'm going to walk you through the flow to help you understand what exactly it does, we do as a service. So first, you can request TLS certificates, right? And you can get them from our publicly trusted CA under Amazon Trust Services. And when you get those publicly trusted certificates, you can use them with AWS integrated services. For example, CloudFront. Go stick a public cert on CloudFront. Now you can terminate TLS. You can also get private TLS certificates from AWS Private CA. And when you get those certificates, you can also use it with the integrated services, but you can also use it with other services by exporting that cert and using it. To monitor these certificates, ACM provides monitoring through CloudWatch and Amazon EventBridge, allowing you to know when certs are issued, when they're expiring, and then potentially even automate your processes and workflows. Now, what if you have a cert that you want to use with some of these integrated services, but you don't want to use the public CA or Amazon public CA or AWS private CA? You can import a cert, right? Provide the certificate along with its private key. ACM will bind that cert to the resource or the service that you want, and will make sure that you can use that cert. And I'm excited to share that today, we announced that we have now exportable public certificates. So let's talk a little bit more about that. So what are exportable public certificates, and why do we do it? We heard from customers that they like getting public certificates from ACM, but they want to use it outside of those AWS integrated services, or ACM integrated services. And so, for example, you could use an ACM public certificate to terminate TLS at CloudFront, but if you wanted to inspect that traffic at a firewall like NextGen, prior to it terminating, you couldn't. You couldn't use that same certificate. That meant you had to go somewhere else, procure another public certificate, and use that to decrypt and inspect the traffic. Now with exportable public certificates, you can use the same certificate to both inspect the traffic as well as terminate TLS at CloudFront, as an example. So what does that allow you to do? One, you get to consolidate, right? You don't have to go to another certificate public certificate provider to get that certificate and use it alongside ACM. The procurement is also very quick. Within seconds, you can get a public certificate on demand. No contracts, no blocks of certificates with the pay-as-you-go pricing. $15 for each fully qualified domain name and $149 per wildcard domain. You also get to use identity and access management, just like you do today with all the other AWS services, to control access and permissions. Not only can you restrict who can call export certificate, you can also use service control policies to say what certificates, restrict them down to even not getting a wildcard certificate, for example. Now, just to let you know, any ACM certificate you've already issued, public certificate you've already issued, can't be exported. So it's not like you can give someone export capability and they'll come in and grab all the certs you've already issued. And lastly, as I mentioned before, we have the CloudWatch events, event bridge events, allowing you to get notified and automate part of your certificate lifecycle process. So now I'm going to pivot to private CA. What is private CA? Similarly, I'm going to go through the flow to help you get a sense of what we do. Like I said, it's a versatile CA managed CA service. It issues private certs, pretty basic. And you can use APIs as CLI and our SDKs to get those certificates. And you can use them with a wide variety of AWS services, whether it is with your containers, whether it is using IAM anywhere so that you can give AWS creds to endpoints, resources outside of AWS on their way in, or with Active Directory, right, through directory service. But there's use cases outside of just the integrated or the services at AWS. For example, you can use it with on-premises, with Kubernetes, even if it's not Amazon EKS, and IoT devices, right? Lastly, common use cases are service meshes, VPN access to corporate network, right? Very common use cases for our private certificates. And as I mentioned before, we integrate with ACM, allowing you to then use private certs on things like load balancers and CloudFront if you would like. Jumping into the key concepts. Let's start with the hierarchy. So what is a CA hierarchy? Start at the top with the root CA. This is your root of trust. This is your trust anchor, if you will. And it comes down to your subordinate CAs that can be intermediates or the actual issuing CAs that issue those end entity or leaf certificates. Right? The big thing to keep in mind is keep your hierarchy simple. Like it's, the more CAs you have, even though it's a managed service, it is just more overhead. Deploy the root CA in its own AWS account. You can take that account and restrict who even has access to it, which helps you protect that root CA even better. And then you could create separate admin and issuer roles. What does that mean? You can create a CA, but that CA doesn't do anything until you have a self-signed cert or a signed cert from a CA above and a level higher. And so you can say, well, this person can create a CA, and this other person can actually issue a cert. Those two people have to come together to get an active CA. Right? So you don't have folks just creating CAs and issuing certs without at least a couple people coming together. And then if you're using long-lived certificates, we provide revocation, as I mentioned. Another concept that we're going to talk, or they're going to share about is cross-account CA sharing, which means you can have a CA deployed in one account using AWS Resource Access Manager. You can share that out with another account, and that account can be within your own organization or a third party, right? And so one thing about private CA, we have tiered pricing, which means that if you share that CA with another account, those certificates add to your aggregate for your tiered pricing. And here's an example of a setup where we have cross-account sharing and as well as the root CA protected in its own account. So in the top right, we have the root CA in its own account, locked down to only a handful of folks who can access it. The security team in the middle now has created an issuing CA and shared it out using AWS RAM to application teams in the bottom right, and then to potential third-party solutions in the bottom left. They may be providing something like certificate lifecycle management. The other concept that we will talk about is resilience. So private CA is deployed across 3 availability zones within a region. However, if you want to have multi-region, cross-region resilience, you can have a couple of options to do that. One is the example we have here, where you have a root CA and an issuing CA within the same region, and then you have another issuing CA in a different region that chains up to that first root CA. Right? Allows you to continue issuing if, for whatever reason, AWS private CA is unavailable in that first region. Another solution is to maintain 2 root CAs. Right? In this example, you would have a root CA in US West 2. And the only challenge there is it adds a little bit of complexity. Right? You have now 2 CA certificates that you're managing within your trust store. But those are your 2 options. I'm going to briefly touch on certificate revocation, right? Like I mentioned, you talk about being able to revoke a certificate. Why would you do that? Especially if they're long-lived, you may have a lot of reasons, like the certificate's private key got compromised. I want to replace that, right? Another good example might be my employee. I issued a bunch of certificates to their laptop, user certs, whatever they needed. They left the company. I don't want those certs to stay valid. I'm going to go revoke them. And as I mentioned, we support CRL and OCSP. Lastly, before I hand it off, just want to share how do you use private CA with things like Kubernetes or Active Directory or mobile device software solutions or mobile device management software. It's through connectors. So we provide a portfolio of connectors that allow you to use private CA through automation, whether it's Cert Manager, Kubernetes, auto-enrollment with Active Directory, or with just the MDM solutions themselves. So wrapping up, AWS Private CA, versatile, whatever private certificates you need, really can support you in issuing those certs at scale with automation. Build on a secure and solid foundation. What I mean by that is every private key is generated, used for signing, and deleted within HSMs. When they're not being used, we sign them or we secure them using HSMs as well. And we meet regulatory and compliance needs, so you can check that out on our website. And lastly, what's the whole point of all this? Really is to avoid outages and improve uptime, right? Like you want to not think about these certificates. You want them just to exist, and that's going to happen through automation, whether you're using ACM to do that, whether it is the connectors and using it with existing automated distribution solutions, or using it with APIs or third parties. So that is my part. I'm going to pass it along to our friends from Fannie Mae.
Thank you, Dan. Hey, very glad to be here. We're going to talk to you about Fannie Mae's journey to using the AWS Private Certificate Authority and its associated services. Okay, I'm Cosmos. I'm an Information Security Engineering and Operations Manager over at Fannie Mae. And that's Nana. He's one of our lead engineers over at Fannie Mae on the security team. Okay, so about Fannie Mae, what do we do? Well, Fannie Mae plays a critical role in the U.S. Mortgage and housing industry. We provide stability, liquidity, and affordability for the U.S. Housing market, and we really are, part of the backbone of American housing. Okay, so onto the technology, the AWS Private CA. Why did we consider it? Because we had many different ways we could have gone with this when we started evaluating, looking at potential alternatives for our internal PKI. Well, part of it was cost, right? AWS Private CA was very, very cost competitive to what we're using previously. I think it maybe came at 1/15 of the cost of our previous CA, and so that was a very compelling reason to consider it. And then compatibility. We use different certificate lifecycle management technologies at Fannie Mae. A very key one for us is Venafi, and the AWS Private CA very, very nicely integrated with that. There was a native driver in Venafi, so it made it a very compelling reason to consider it. There was also the scalability and availability of the infrastructure, because AWS manages all of that. They scale as needed to meet whatever demand we have. And it's a managed service, right? There's no infrastructure for us to manage, nothing for us to patch, upgrade, deal with, OS retirement cycles that can come from, traditional ADCS CA architectures. And so that was part of the reasons why we considered leveraging the AWS Private CA service. So how did we pull this off? Well, if you are in the PKI space, you know that, folks generally know that they need a certificate for TLS to secure their databases or their websites and whatnot, right? But not everyone fully, thinks all the way about, how the PKI infrastructure works with trust stores and all the accompanying parts. And so part of it was extensive communication, right? We let folks know, okay, this is happening. We're transitioning to a new route. We need to establish trust for this new route. We held office hours because everybody had a different, technology, perspective. Some folks had applications running on mainframes, right? We had folks that had Java, native Java applications, Python-based applications. Like, how do I adapt to this new root hierarchy? We also staged our migration, right? We didn't just cut over everyone at once. We did it incrementally. We did a lifecycle-based, migration path. Starting with our sandbox environments to development, user acceptance, and then all the way to production. And then something that was very, very key for us is we did two things. We stood up like an endpoint for our managed trust bundles, where development teams could go and pull down these bundles. They could consume them either at runtime. Some folks decided to pull it down, store it, and build it into their applications. And we also stood up an endpoint for folks to validate trust against the new CA hierarchy. So they could just make any kind of web requests, right? We provided code snippets, examples of how they could do this. Go make this, HTTP web request to this endpoint that we stood up. And if you get the right response, then you know that you trust this new route. And I'm going to hand things off to Nana. He's going to talk about the engineering flow and the architecture for our AWS private CA hierarchy.
All right, thank you, Cosmos. Hey, am I audible? Great. All right, so I'll talk about how we've integrated AWS Private CA in our current PKI infrastructure. I'll start by saying or stating the high-level flow of how all of this happens. So we have our client apps that require certificates, right? So they call our certificate lifecycle management tool. Our main one, which is Venafi right now, and then Venafi generates certificate sign-in requests, sends it over to the AWS private CA. The CSR is processed, sent to Venafi, and then back to the client, right? So just to go into a little more details on how all these pieces tie together. So I'll say the main two things that we needed to make this work were Venafi, I'll say. So Venafi itself has inbuilt ACM drivers that allow us to integrate with the AWS ecosystem to manage private and public certificates, right, across multiple regions. So that's the first main thing. And then the second thing is obviously permissions to interface between the CA service, right? So we run our Venafi application on load-balanced EC2s. And then the EC2s have instance roles attached to them, and then the roles have permissions required, and it interfaces with the CA service, right? So we do not allow direct access from our client apps to the private CA. Venafi is the intermediary, right? So as far as our clients, how they get to the CA, we create API profiles within our Venafi, and then we categorize our clients into the applications that reside on-prem and the ones that reside in the cloud. So, for on-prem, we have a custom-built certificate generation tool that we call CertGen, and all of its underlying resources are, AWS services, specifically ECS and then Lambda. So, just listens for certificate requests that application teams request via ServiceNow forms. And then same flow as I mentioned, process it, Venafi processes it, and then sends to our AWS private CA. And then we have our applications that reside in the cloud, right? So we have the ones, and with those two, we categorize in subcategories too. So ones that deploy through our legacy pipeline that we call Urban Code Deploy UCD by IBM, and for those particular clients, we have a dedicated Lambda that listens for certificate requests. And then we have applications that deploy through Terraform and GitLab as well. So as far as scalability goes, as our infrastructure continues to scale across multiple business units and their workload requirements, a solution or a CA solution like AWS Private CA is simply ideal, right? Because a CA solution that can scale automatically in the back end and dynamically without us having to provision any new infrastructure, right? So to support our resiliency requirements, we deployed 2 root CAs in distinct regions, right? So one in our Northern Virginia region, and then another one in our Ohio region. And then we have our automation utility round robin between the two, right? So, and one thing that we made sure to enforce amongst the support teams is the need to have the CA sets for these two CAs in their trust stores. So in case there's a failure in region 1, we just fail over to region 2 and we have continuity of services. From an end-to-end perspective, we integrate our PKI infrastructure integrates with multiple AWS services, right? So we have ACM for our certificate inventory and expiration notifications. And obviously today with the announcement of exportable public keys and certificates, we might be doing more with ACM. And then we have AWS Cloud HSM, which we use for encrypting our Venafi database key. And then we have another use case for code sign-in, and those keys we store on our Cloud HSMs as well. And then we have AWS Lambda, like I mentioned, dedicated for certificates requests. And then we have a separate AWS Lambda that handles backups from primary Cloud HSMs to a secondary region for resiliency requirements. I'll turn this over to Cosmos to speak on.
Thanks, Nana. So we definitely learned a lot of things going through this journey with AWS Private CA. One important thing was PKI education, right? Application teams want to be enabled to develop apps, quickly and effectively and efficiently. And it was critical for us to definitely meet them where they were at, help them understand how PKI works within Fannie Mae, let them know the requirements and how to build their applications in the crypto agile way where they were able to adopt the new routes as needed. We really start to work on this education, pipeline, making sure folks really understood this is how PKI works within an organization. So the next time we have to do a journey like that, which we're going to get into with the post-quantum certificates, it's not as difficult because we have those learnings and those that knowledge built into our organization. Now, key part was identifying platform owners. This gives you the biggest bang for your buck when you're doing a transition like this, right? We definitely went to like a centralized Windows teams where they could deploy the new routes using GPO to all the Windows endpoints, both servers and workstations, right? Same thing for our Apple and Mac teams, using the mechanisms to deploy the certificates to the trust stores. Even we leverage AWS Server Manager for our Linux compute, right? For existing instances, we're able to push the new routes to the right trust store locations across Fannie Mae. And then also, think about development tooling, right? So our internal versions of Java that we maintain, Python, we had to go find who owned these platforms, bake it in there, right? So when it's consumed or if it's even containers in the container registry, you can consume it directly. That way, it makes it easy because our application teams already have built pipelines where they can just easily redeploy the applications, and they don't have to go figure this out. Like all they need to do is, okay, I see that the latest container has the new certs baked in. I can just plan a new deployment for my application, redeploy that. I'm good to go. That was a very critical lesson for us. And then we also had 2 more items I'm going to have Donna talk about.
So, like Cosmo said earlier, right? Throughout the migration, journey, what we noticed was there was a lack of fundamental knowledge in PKI across multiple application support teams, and then we responded by posting detailed and extensive documentation or publishing extensive documentation accessible for all application teams. And I could say over the period, the knowledge across the enterprise when it comes to PKI is has improved greatly. Yep. And then this is, as far as inventory of custom trust stores, this is an issue that we honestly kind of still deal with. Not as much, obviously, during the migration. Was there were application teams that built custom trust stores that may override whatever their platform's default trust store is, right? So With PKI and migration of CA doesn't happen as often, so they don't touch their client trust stores that much, and then they lose track of where their trust stores are. So we had to help most of these application teams find where their trust stores are, even though we did not build it, right? So as far as where we're heading with our PKI strategy, the most immediate that we're currently working on is a CRO distribution point that's internally accessible. So at Fannie Mae, it's a requirement to send any traffic going to the public internet through a proxy, right? So what we're finding is there are some critical applications that are simply not proxy aware. So with the AWS private CA, the default OCSP endpoints and CRO endpoints are hosted on the public internet, so these critical apps cannot perform revocation checks, right? So we've currently in our dev environment, we've built something that's being tested. So we, if everything goes well, promote to production. For the most part, AWS private CA gives us all the key usages we have, but there are some one-off use cases where an application team might need a certificate for token signing or non-repudiation, right? So that so far I haven't seen that AWS private CA has, so we want to have the conversation with AWS private CA, the AWS team, and then see if we can introduce that in Fannie Mae. Turn that over to Cosmos.
And then we're also obviously preparing for the post-quantum world. PQC is going to present challenges for the entire PKI industry, folks that run internal PKI practices, and also for public TLS. Right, so we're paying a lot of attention to what AWS is doing to pioneer and lead in that space, so we can learn and adopt those learnings into what we do internally. Fannie Mae often follows the CA browser farm requirements for our internal PKI as well, and so things like 90-day TLS and it's going down and down. I think I saw the other day Apple presented maybe a case for us at 47-day certificates. Right, we have to adapt to that world. Right, we're thinking a lot about how do we enable our teams to do this, because part of our thinking is we have really good understanding of how we deal with certificates, even short-lived certificates internal to organization. But you're going to have relationships with third parties that host websites for you that you need to secure with certificates. Right, when certificate durations started off at 5 years, 3 years, now currently 398 days. Sure, it's manageable. You can have a rotation schedule that is reasonable, and you can work with those third parties. But as the durations keep ratcheting down to 90 days and lower, it gets a little bit more challenging. So you have to automate, right? There's going to be a very huge push for that. We're going to work with our partners at AWS to design probably new ways and new mechanisms where these third parties can consume certs and make certificate proliferation internally and for our external partners much easier. And then we're going to talk about some best practices. I believe Dan, that's you.
Thank you. I'll take this. All right, we'll wrap up real quick with some quick hits on best practices for AWS Private CA. We'll talk about the key takeaways, and that will wrap us up. So overall, we have a bulleted list of things, but it really comes down to be intentional. Right? Take time to document what you're going to do. Think about your CA hierarchy. Think about validity periods at the time of CA creation. Right? Once you issue a cert, once you stick a CA certificate into a trust store, it's a lot of work to rotate that trust store if you want to go change something. As I mentioned before, keep the root CA in a separate account. That really helps prevent access from folks you don't want. Define the end entity validity to be less than the issuing CA. And lastly, use AWS RAM to share your CAs like Fannie Mae did, not only with your application teams or with third parties, but you can also do it with your application teams, right, to optimize your private CA usage. Two things we always say you should not do, or we don't recommend you do. One is don't issue from the root CA, right? You should trust It's your anchor of trust, your root of trust. You really want it to only issue subordinate CAs, so that way if something goes wrong, you can revoke that subordinate CA cert and boom, all those certs down stream from there is not trusted. And you don't have to do a whole trust store rotation, which you heard is kind of a pain. Don't pin to intermediate CAs. Intermediate CAs tend to have shorter life than the root CA, and really it makes it harder for you to understand your trust boundaries as if you start pinning to intermediates. And let's wrap up here. So key takeaways from AWS is we have two certificate services, AWS Private CA and ACM. One allows you to issue private certs. The other allows you to issue public certs that are both public or TLS certs that are both public and private. And as we shared today, not only can you use ACM TLS certificates with these integrated AWS services, you can also use them anywhere now, whether it's workloads on EC2, whether it's workloads on-prem, or in some other hybrid multi-cloud environment.
And then when implementing private CA, we just learned keep it simple. You lose your audience if you make the ideas and things you're trying to express about a PKI transition very complicated and very confusing for them to understand. Use simple analogies. One I was leaned on was the whole idea about a certificate being analogous to like a passport, and the passport office is like the issuing, and it's the trust anchor. So make it easy for folks to understand and meet you so that they can understand what they really need to do. The other thing is trust store management is hard. It's challenging. PKI is a very decentralized system, right? And so, there aren't many opportunities to do centralized management. But when you find those opportunities, lean into them. Earlier in the slide, we talked about the relationships we built with our platform teams. So where we could build these certificates, directly into pipelines, directly into container registries, into the operating systems themselves. Lean into those opportunities, right? Because they're going to make it very, very simple for you to manage your trust stores, keep them up to date, and making sure you're well equipped if you ever need to do a transition like this, now or in the future. And then using a generational naming convention. That's what we did at Fannie Mae. That just makes it, because we know this transition might not be the last time we have to do this, right? So we're going to have to potentially do this, especially with the post-quantum world that we're soon going to live in. So being able to make sure you have a good naming convention for your certificate authorities and a good and solid hierarchy makes it easier to make a transition like this.
All right. And that's our session. Thank you so much. Please connect with us on LinkedIn. Please share the session. And we will be right down here if you have questions for any three of us. Thank you so much.